हेलो स्टूडेंट्स, हाउ आर यू। होपफुली बहुत अच्छे होगे बेटा। देखिए, सॉलिड स्टेट में हम जो स्टडी कर रहे हैं उसमें मैंने आपको क्लोज पैकिंग इन 1D 2D 3D एक्सप्लेन करा। जब आप 3D स्टडी कर रहे थे तो हमने वहाँ पे कुछ वाइड्स के बारे में भी बताया। व्हेन वी प्लेस्ड वन लेयर एंड देन सेकेंड लेयर देन थर्ड लेयर, स्क्वायर क्लोज पैकिंग और हेक्सागोनल क्लोज पैकिंग, दोनों ही केसेस में हमने स्टडी करा। जो बेटा आप 2D हेक्सागोनल क्लोज पैकिंग से 3D हेक्सागोनल क्लोज पैकिंग बनाते हो तो आप देखते हो कि फर्स्ट लेयर के बाद जब हम सेकेंड लेयर प्लेस्ड करते हैं, ठीक है, ओवर द 2D हेक्सागोनल क्लोज पैकिंग, then two new type of voids are formed. One is octahedral void, another is tetrahedral void. We discussed about octahedral void in detail and also we find out the size of the octahedral void. Now I am going to discuss how can you find out the size of the tetrahedral void. As you know, in the FCC or CCP close packing, octahedral voids are placed at all edge centers as well as body center. While if we talk about tetrahedral voids, all tetrahedral voids are placed on body diagonal near the corner inside the lattice unit. So we can say, if we talk about tetrahedral void, this is the corner, this is the FCC unit. I just pointed out only one corner. This is the corner one. These spheres, all these spheres are the face centers. This is the face center of this one, this is the face center of this one, and this is the face center of the back side. When we join all three spheres as well as the corner, we get a tetrahedral void, that is the void covered by four spheres in which three spheres are in one plane, one above it. This is the tetrahedral void formed between all these three and four spheres. These three are in one plane and this one make a tetrahedral void with this one. Now, if A is the edge length of this unit cell, A is the edge length, suppose if A is the edge length, okay, then you know this is the face diagonal. The face diagonal length is 2r. Sorry, face diagonal length basically is root 2a, but this sphere is at face centered, so the distance of these two spheres should be the half of the face diagonal. And because these two spheres should touch to each other, if we talk about this is the tetrahedral void, so if these two spheres are touch to each other, then this length becomes equal to 2r. Okay, and now in terms of edge length, this length will be the half of the face center, face diagonal, half of the face diagonal, root 2a by 2. Similarly, I already explained sphere touching along the face diagonal at face center, ये आपस में टच कर रहे होंगे और ये आपको tetrahedral void मिला है. Similarly, जो tetrahedral void है, it will placed at the body diagonal. Whole length of the body diagonal is root 3a. ठीक है, body diagonal पर बेटा जो tetrahedral void form होता है, it is formed at 1/4 distance of the whole body diagonal. This length should be the 1/4 of the whole body diagonal. The whole body diagonal length is root 3a, and suppose its radius is capital R, its radius is small r. So the sum of these two should be the 1/4 of the whole body diagonal. So 1/4 of the whole body diagonal. We get these two equations with reference of this FCC unit cell. Now it would be simpler. It would be simpler to find out the radius, that is the radius of the tetrahedral void. Two equations are formed. Solve these two equations. On solving, इसमें आप इसको divide कर दो. Finally, you get the maximum size of the sphere that can be placed to the tetrahedral void is 0.225. Okay. ये बेटा काफ़ी यूजफुल है, आपको साइज पता होनी चाहिए इसकी कैसे निकालते हैं. सो ये एक तरीका फाइंड आउट करने, यू कैन वॉच इट again and again and you can understand. It may be asked in the subjective exam, in the board exam, CBSE, ICSE or in the state board exams. Okay. Now, how can you determine density of the solid? As you know, usually it's a very simple term, density. Density means the ratio of the mass of the unit cell divided by volume of the unit cell. That is the mass of the solid divided by its volume. That will give you the density. Absolute density, calculation of density, mass of the solid, volume of the solid ratio. Mass of the solid means that is the crystalline solid. If you find out for one unit cell, then you can consider mass of the one unit cell divided by volume of one unit cell, because you know in any crystalline solid units are repeated in all three dimensions. ओके, सो अब एक यूनिट सेल की जो डेंसिटी होगी वही पूरे सॉलिड की डेंसिटी होगी. नाउ मास ऑफ द यूनिट सेल, यू नो, in one unit how many number of spheres are there, and mass of one sphere, how many number of total spheres multiplied by mass of one sphere, it will give you the mass of the whole unit. Number of spheres in the unit, one unit, multiplied by mass of the sphere, mass of one sphere divided by volume of the unit cell. Simply suppose that is the number of spheres in one unit cell, and m is the molar mass of the sphere. Sphere may be atom, may be molecule, may be ions. We can find out mass of one sphere, it's a molar mass. By dividing Avogadro number, you get mass of one molecule, one atom. And the V is the volume. Z number of spheres hai. Z may be 1 for simple cubic, maybe 2 for body centered cubic, maybe 4 for face centered cubic. Z number of spheres, M mass of the sphere, molar mass, that is the mass of 1 mole atoms or spheres. That's why we divided here by Avogadro number, so that we get the mass of a single atom in gram or kg. Na Avogadro number, V is the volume of the unit cell, and if we have unit as a cube, then the volume of a cube we can write as a cube. और इस तरीका से आपको यहाँ पे डेंसिटी का फॉर्मूला मिल गया. Z की वैल्यूज ये होंगी, इससे हमें टाइप ऑफ यूनिट सेल पता लग जाता है. कई बार कई क्वेश्चंस में हमें डेंसिटी गिवन होगी, टाइप ऑफ यूनिट सेल पता लग जाएगा, एज लेंथ गिवन होगी, वॉल्यूम फाइंड कर सकते हैं, और एज लेंथ नहीं है रेडियस भी गिवन हो सकती है, तो उसके बेसिस पर भी हम फाइंड आउट कर सकते हैं वॉल्यूम. ओके, जैसे देखिए कैलकुलेशन ऑफ डेंसिटी for the simple cubic, you know, if we have a simple cubic unit, this is the simple cubic unit cell. All spheres touching to each other along the side, because ये touch कर रहे होते हैं, so here A is equal to 2R, because spheres are touching along their sides like this. ठीक है. इसके अलावा यहाँ पे कितने नंबर ऑफ स्फीयर्स होंगे, यू नो, देयर आर 8 कॉर्नर्स एंड एवरी कॉर्नर कंट्रीब्यूटेड इट्स 1 by 8 part, so total 1 sphere is there. So if we talk about the simple cubic, whenever we needed the value of as length, the radius of the sphere is given, we can put, और z की वैल्यू चाहिए ये रख लेंगे. ठीक है. Similarly for body centered cubic, for body centered cubic unit, in most of cases this is the body center. इसमें बेटा आपको पता है जो body center sphere होता है, this body center sphere actually touch to all corners, similar like this one. Spheres are touching to each other along the body diagonal. Simple cubic spheres are touching along to edge length. Okay, so here you can say if it is R, this is 2R and this is R, this whole length, as you know, it becomes 4R, and this is equal to root 3A. If A is the edge length, root 3 will be the body diagonal, so 4R is equal to root 3A. Okay, यहाँ से आप edge length find out कर सकते हैं whenever you needed edge length for the volume. As you know, volume is the A cube. यहाँ पे number of spheres कितने होंगे बेटा, 8 corners contributed 1 by 8 plus 1 at body center, it gives the 100% contribution. Value of Z is 2. ठीक है. This is for BCC. Data needed we can use to calculate density. If we have to talk about the face centered cubic, FCC, face centered cubic, as you know, spheres are present at all corners. In the face centered cubic, spheres are present at all corners as well as at each face center. Okay, this is the FCC. This is also known as CCP, cubic close packing. In this case, the value of Z, total number of spheres in one unit cell, we can find out 8 at corners, 6 at face centers, so we get 4. And if we talk about the relation between as length and radius, here as length and radius, actually here the spheres touching to each other along the face diagonal. This is the face diagonal like this. Spheres touching to each other along the face diagonal. This length is if this is A, this one is the A root 2 and it should be equal to 4R. Use these relations to calculate the density for the simple cubic, body centered and face centered unit cell. अगर हमें इस टाइप के क्वेश्चंस दिए जाएंगे हमें कोई प्रॉब्लम नहीं होगी, हम फाइंड आउट कर लेंगे. कोई एग्जांपल देख लेते हैं इसमें. ठीक है, डेंसिटी का फॉर्मूला ये यूज होगा. जैसे आपको एक क्वेश्चन दे रहा हूं जस्ट फॉर द प्रैक्टिस. सपोज वी हैव टू डिटरमाइन, वी हैव टू आस्क, कैलकुलेट density of cesium solid having BCC packing if its as length, हो सकता है एज लेंथ डायरेक्ट गिवन हो, ठीक है, और हो सकता है आपको रेडियस गिवन हो. तो हमने यहाँ पे बीसीसी बोल दिया. अगर मुझे यहाँ पे सीजियम की रेडियस गिवन होती देन आई यूज द फॉर्मूला √3 इक्वल टू 4r टू फाइंड आउट द एज लेंथ. और अगर एज लेंथ डायरेक्ट गिवन है देन नो प्रॉब्लम, आई कैन फाइंड आउट द वॉल्यूम एज ए क्यूब. अदरवाइज ए शुड बी फाइंड आउट फ्रॉम हियर by this relation, and because BCC is given in the question, so we get the Z value of 2. Now if we have to find out the density, change the values in appropriate unit and put in this formula, we get the answer. Okay, BCC FCC कुछ ऐसे हो सकता है density given हो, Z find करना हो सकता है आपको सारी चीजें given हो, even Avogadro number find करना हो, but in this case calculation would be slightly difficult, so please calculate very carefully, or you can calculate in the approximate calculations. Okay, but still if calculations are much more difficult, sometimes we have to find out the volume as a cube, a find out as this one, then the cube, or sometimes we have to calculate cube root, so it would be difficult slightly in the mathematical calculation. So you can consider approximate calculations, but in the most of cases, if we talk about in the board exam, or if we talk about in the competitions, calculation would be very simpler, or very little time consuming, so that you can find out easily the calculation of density. Okay, so this is the whole concept about to calculate the density as well as to find out number of units as length relations, and how can you determine the size of the tetrahedral void. Okay, so dear student, just watch it and practice more number of questions based on the calculation of density as well as based on the relation between as length and radius for all simple cubic, A is equal to 2r, body centered cubic 4r is equal to √3a, and face centered cubic A √2 is equal to 4r. Okay, watch it. अगर आपको कोई इसमें प्रॉब्लम है, कोई दिक्कत आ रही है, ठीक है, then you can call me or message me as usual. Okay, thank you, thanks a lot.